So for section 7.2, we're going to talk about integration by parts. And chapter 7 is going to be dealing with all different types of integration techniques. And integration by parts is used when you're dealing with the integral of a product. And as you know, there is no product rule for integrals, but this is one way or one technique we can use to integrate when you have a product and your integral. So when you have the integral of f of x times g of x, the method we can use to integrate is going to be called our integration by parts. And the proof of where this formula comes from is actually derived from your product rule. If you're taking a look at the derivative of a product, we know that's u times v, the u prime v plus uv prime. And then if you integrate both sides of this equation, we're going to integrate the derivative of u times v, which is equal to the integral of u prime v plus your integral of uv prime. So that's going to leave us with uv is equal to the sum of these two integrals. And then if you solve this for u times v prime, we end up with uv prime is equal to uv minus your integral of u prime v. And then again, this is the derivative, so u times dv. And again, if you do a substitution, let's let v prime be equal to dv and let u prime be equal to du. We can rewrite our integral, and then we end up with our formula for integration by parts. So again, here is my formula for the integration by parts. U times v minus your integral of v times du. So the trick when you're doing integration by parts is what you're going to let u be equal to and what you're going to let dv be equal to. So again, when we're doing our integration by parts, the formula we're going to be using is u times v minus your integral of v times du. That's the formula for parts. So when you're doing your integration by parts, for example, if I want to integrate x times cosine of x, the thing is we need to make a choice for what we want u to be equal to and what we let dv be equal to. So let's suppose in this case I'm going to let u be equal to x, my algebraic function in the integral, and dv be equal to cosine x, my trig function. So if I let u be equal to x, what I then want to do is I want to differentiate u. So then du is going to be equal to dx. dv is equal to cosine x. And what you want to do is you want to integrate whatever your dv is to come up with your v. So I know that the integral of cosine x is going to be sine x. So for parts, you've got to know a u, you've got to know a v, you've got to know a dv, and you've got to know a du. So now I'm going to plug everything into my parts. So again, u times v minus your integral of v times du. You then should be able to get an integral that we can integrate. So u times v is going to give me x times sine x minus your integral of v, again we found that to be sine x, times my du, which is just dx. And notice we can integrate sine x. So my answer is going to be x times sine x minus, now be careful, it's the integral of sine x is a negative cosine x, that becomes a cosine x. And again, this is an indefinite integral, so don't forget to add your c. Don't forget that when you're integrating sine and cosine, the SC, SCS, remember, these are your two negatives. When you go down, these are your derivative rules for differentiating sine and cosine. When you go up, those are your integral, because we are going to be integrating sine and cosine and differentiating a lot within the same problem. So the trick is, like I said, the strategies for selecting u and dv, because that's what you have to be careful of when you're doing integration by parts. So we want to choose u so that the derivative becomes simpler, and dv is easy to integrate to find v. So here's that phrase LIAT that will help you. So the L stands for logarithms, I is your inverse trig, A is an algebraic function, T is your trig, E is your exponential. So what we use this for LIAT for is it's just a mind, it's a word, to help us identify, we want to take u to the functions whose category occurs earlier in the list. So again, look at this list and identify what your u is going to be. This method doesn't work all the time, but sometimes it works. It helps us. So for example, you have an inverse trig dx. So notice you only have one function in this particular integral. So we're going to let u be equal to the inverse tangent, and actually I can let dv be equal to my dx. Same thing with natural log of x, a logarithm. We'll let u be equal to natural log of x and dv be your dx. If you look here, you have an x squared times e to the x. So x squared is just an algebraic function. E to the x is an exponential function. So in my list, when I look at Lie 8, algebraic functions come before exponentials. So I'm going to let u be equal to my algebraic function, and dv is my e to the x. Here I've got an algebraic function and a trig function. Again, notice my algebraic function comes before trig, so I'm going to let u be equal to x squared, and dv is going to be equal to sine x. So let's take a look at some examples here. So here's the first one, the integral of x times e to the x. I have an algebraic function, I have an exponential function. So again, in my word Lie 8, algebraic comes before exponential. So I'm going to let u be equal to x. My dv is going to be equal to the other function, which is my e to the x. I'm going to find my du. So I differentiate x, that's just going to leave me a 1 times dx. I want to integrate to find v. So v, the integral of e to the x, is just e to the x. So now I know my u and my v. So again, I can plug into my part, so u times v minus your integral of v times du. So u times v, so x times e to the x, minus your integral of v, which is e to the x, times my du, which is dx. And now I'm going to integrate. So x times e to the x minus e to the x, and don't forget your c. So looking at b, notice the functions you have inside your integral. You have an algebraic and you have a logarithm. So notice logarithms at the top of my list in terms of Lie 8. So I'm going to let u be equal to the natural log of x. My dv will be equal to x. So du is going to be equal to the derivative of natural log of x, which is going to be 1 over x dx. When I integrate x, that's going to give me my v, which is going to be an x squared over 2. So now I want to plug into my part, so u times v minus your integral of v times du. So u times v, so I have natural log of x times x squared over 2, so x squared times the natural log of x all over 2. There's my u times v. Minus my v, which is x squared over 2, times my du, which is 1 over x dx. Now before we integrate, you want to clean up this integral as much as you can. So again, I can cross cancel an x, and I can pull a 1/2 out of my integral. So I still have this x squared natural log of x over 2. He's just going to tag along to the final answer. So I have minus 1/2 times your integral. Again, the x's will cancel, so I'm going to be left with an x dx. So I have x squared minus, this should be a times, excuse me, I wrote a subtraction sign there. X squared times the natural log of x. X squared times the natural log of x all over 2 minus 1/2 times, when I integrate x, that's going to give me an x squared over 2 plus c. So I have x squared times the natural log of x all over 2 minus 1/4 x squared plus c. So there's for part B. So for C, notice the two functions you have. You've got an algebraic function and you've got a trig function. So in the word Lie 8, you've got the algebraic function comes before trig. So I'm going to let u be equal to x. My dv will be equal to the sine of 3x. So when I differentiate x, my du is just going to be my dx. Now be careful when I have to integrate sine of 3x. I have to do a u sub. U is equal to 3x. My du is equal to 3 dx. So I have to pull that 1/3 out of your integral. So 1/3 times your integral sine of u du. And again, so now when I integrate, v is going to be equal to 1/3. The antiderivative of sine is going to be my negative cosine, and I can plug back in my 3x. So I have negative 1/3 times the cosine of 3x as my v. So now I want to plug into my parts, u times v minus your integral of v times du. So again, u is just my x, times v, which is negative 1/3, so I'll write that as negative x over 3, times the cosine of 3x. So there's my u times v. Minus your integral of v, which is a negative 1/3 cosine of 3x, times du, which is just a dx. Again, you want to clean up this integral as much as you can before you integrate. So here's my part that's just going to tag along, the negative x over 3 cosine of 3x. I'm going to pull out my constant of negative 1/3, so that's going to be plus 1/3 times your integral of cosine of 3x dx. So now to integrate cosine of 3x, I have to do another u sub. U is going to be equal to 3x, du is equal to 3 dx. So I have to divide a 1/3 out of this integral, so this constant is going to be plus 1/9 times your integral of cosine of u du. And again, you have the part that's just tagging along. So now I'm ready to integrate the cosine of u, which I know the antiderivative of cosine is going to be a sine. So my final answer is going to be my negative x over 3 cosine of 3x plus 1/9 times the sine, and I'm going to bring back in that 3x for u, plus c. So there's c. Now for part D, we have the natural log of x. I'm just going to do this on a separate sheet of paper since I've So for part D, we have the natural log of x. So we have no rule on integrating the natural log of x. So notice I have a logarithmic function, and that's the first thing that comes in my Lie phrase. So I'm going to let u be equal to the natural log of x. My dv is just going to be equal to my dx. So when I take the derivative of natural log of x, that's going to be 1 over x dx. The integral of just dx is going to leave me with an x. So again, I need to plug into my part, u times v minus your integral of v times du. So now plug in u as my natural log of x, v is an x. I'll write that as x times the natural log of x, minus your integral of v, which is x, times my du, which is 1 over x dx. So clean up your integral before you integrate. So I have x times the natural log of x minus x over 1 times 1 over x is just a 1. So that's just going to leave me with a dx. So my final answer will be x times the natural log of x minus x plus c. So that is the antiderivative of natural log of x.